So Arnav, now that you're applying for a junior engineer position at Chintu Sales, we would like to ask you a question. You're applying for junior mobile engineer role at Chintu Sales, where I am the senior junior engineer.
अरे कहना क्या चाहते हो?
Okay, can you help us understand, like, for in general, what are the different challenges that mobile engineers face when they're designing, let's say, an app? So at a very high level, maybe we can think about a particular app like, let's say, Swiggy, or let's not go there. That'll be your ex-competitor. Let's head back to which one should we take? Amazon, let's say. Yeah.
Right.
So how do we go about doing this? Firstly, yeah, I agree that Amazon is a huge app. It's got a lot of functionalities, but just to start off with, what do mobile engineers do when it comes to something like this?
Right. So like the general understanding and the knowledge that is in the industry is, okay, so this is mobile is going to be the UI. So there's going to be some API and it will just sort of get the data from there and just show it on the screen, which is at a broader level, right? And then that's the general perception of, say, a front-end engineer or a mobile engineer, is that this is all about just consuming some APIs and showing, right? The thing is that where the sort of differences start happening and the complexities start happening is that when somebody's starting off with mobile development, generally nobody usually starts off like writing their first line of code as an Android app or iOS app, right? They generally start writing code as, find the sum of 10 numbers, an average of some numbers, and something. It's a command line program. That's generally you do C out, C in, scanner out, something like that, right? When you've done that for a while and people would be like coding in that format for 6 months, 8 months before they are gonna even start with UI development, Android development, is to sort of flip in their head the concept of the flow, right? So everybody thinks that, okay, if I tell somebody, okay, you have to make an app where you have to get 2 numbers from the user and get the sum of it. That's all you have to do. And then some people would have done the same program when they have done basic programming, and they would start out, okay, read the first number from the user, read the second number from the user, and then sum them and, A plus B and C and print C. And now what happens when mobile development is the major shift that happens is that think of this as in an app format. The app of this would look like there would be 2 input boxes where people would come and input data, right? And then they will press a button, which is a plus button or a sum button or something like that, right? And then they will see the result on maybe the third box somewhere. Now, if you imagine an app like this, what stops the user from entering the second box input first and the first box later? Nothing stops them because there are 2 input fields. User can come and enter anything. So where does your logic actually start? Your logic starts when you press the plus button. Now, this is a very important shift as a mindset when you're thinking of mobile development, is that it has to be very event driven, is that events that the user generates, that's where your logic starts. You can't drive the user will drive the app. Right? So it's not like an output comes, please enter number 1. And then the only thing the user can do is enter number 1, nothing else they can do. That's on command line. Now here the user can press the button before entering the numbers also. So you have to check, okay, did they enter the number 1? Did they enter number 2 or not? Now this is sort of like a shift. I feel like I have taught a lot of engineers who have gone from never working on UI or front end or mobile development to this world. And I say it's like a pre-on-click and post-on-click world for them. Like, do you understand that your code starts from on-click or not?
Yeah.
So you would have an on-click function. The on-click function is triggered when the button is clicked. You don't call that function. And that's a very important thing. Like, it's a hard concept to wrap around your head in the initial days. And then, people who have done this for a while might think that, hey, why is this person not understanding this? But what do we learn? That we define a function and then we actually call that function. In mobile development, that's not how it happens. So, actually, I can just use the whiteboard for a while.
Right. I was just trying to think about my drawing skills, and I know it'll suck, but still, just to kind of help out, you are basically saying there's 2 input buttons. Oh, I'm sorry for this. Yeah. Okay. This is another input. So you have input 1, input 2, and then you have this cool submit button, which kind of, let's say this is in. So okay, now this is what we have, and I'll just color it with blue or something.
Yeah.
You can see my design skills are amazing. There's a reason why we have it. Yeah. Also, let's say that these are the input buttons. Okay. So now what you're claiming, I don't believe you at all.
ਹੱਸਦੇ ਚਿਹਰਿਆਂ ਦਾ ਮਤਲਬ ਇਹ ਨਹੀਂ ਹੁੰਦਾ ਕਿ ਉਹਨਾਂ ਨੂੰ ਕਦੇ ਕੋਈ ਤਕਲੀਫ ਨਹੀਂ ਹੁੰਦੀ ਉਹਦਾ ਮਤਲਬ ਇਹ ਹੁੰਦਾ ਕਿ ਇਹਨਾਂ ਨੂੰ ਤਕਲੀਫਾਂ ਨਾਲ ਡੀਲ ਕਰਨਾ ਹੁੰਦਾ
is that you actually have input 1 and input 2 and then you have this submit button over here and people can type input 1 first, input 2 first, and then they can delete some part of input 1 or input 2, and then you basically are saying that, you know, in the console you would have taken this one by one. Yeah. And then you wouldn't need a submit button because, you know, everything is a submission. Okay. While here, like, for all you computer programmers and all the people who are like more into lead coding than actually solving problems, this is something which is quite different because it's actually to be honest with you, Arnav, it's also in that sense like when you click on the submit button, that's if you're a backend engineer, you can think of this as an API call. Like, yes, you can get an input at any second in time. All you have to care about is when they actually send you this request here.
Correct.
Right. So they have an input, they have an output. You have to run validations, like you said, that have they actually put those things or not. That comes here, and then you actually start processing the request here. Is it similar in that sense? Even in the mobile, like you have your own kind of like teeny mini server which is doing this stuff.
Yeah. So like comparing to, let's say in a server's case as well. So what happens is that we learned like when we're doing basics of programming is that, okay, you define a function and then somewhere in your code you call the function. Like you start off with a int main function, you write your code inside the int main, and there is no phantom person, like some ghost is calling your code. That does not happen, right? So you start running your code, things happen from int main, and then most programming languages would have a concept of main, and if it does not, then at least language like JavaScript, they will just execute a code in a serial order, right? Now, what happens with mobile development is that you have to create a function which will supposedly get called when somebody clicks on the submit button, right? Now,
okay. That's
the concept that's harder to sort of wrap your head around in the initial days is that you are never going to call that function yourself. Now, you tell the OS that, hey, I have created this function. Please call this function whenever somebody clicks the button. So you attach that function to the event of the button, right? And they will click the button, the function will get called. And people might think that, hey, in my code base, wherever I have written my code, I have never called that function ever. But the code that is inside the function is still getting executed because the OS is going to call that function for you when the button is clicked. So that is sort of a important thing to sort of understand in the early days. Once you start thinking that way, then it becomes very natural that everything is event driven. You just create functions, attach it, and this then starts scaling up. This is not just about a button. Like, how does your screen get shown? Now, again, say for example, in iOS there are delegates, and Android there is activities. Now, these things also, you write the logic, but you never call the constructor yourself. You don't create a new activity, like you create my activity, and then you never do like my activity m equal to new activity. You never do that thing. Once you define an activity, right? When somebody opens your app, the OS creates your activity. In fact, if you actually construct that activity object yourself, it will never open your app. So the OS has to open that activity for it to actually work, because that's the way the system is designed at the operating system level.
You're telling me that it has, I mean, in the activity, do you define a constructor or you don't define a constructor also?
The activity constructor, generally you don't override the constructor. You don't need to do anything with the constructor at all. Whoa. Because the constructor is called by the OS. So you generally have hooks inside the activity which says that the activity has been created, or the activity has been stopped, or the activity has been destroyed, like somebody has gone out of your app. So there are different lifecycle hooks, and then generally the lifecycle looks like somebody opens your app, and then somebody might pause your app and go to a different app for meanwhile, and then come back to your app. So a resume happens. So there can be a pause and a resume, or there can be a destruction of the activity. Somebody sort of goes to the the app list and sort of swipes away your app. Right?
Yes.
Destroy. And a stop generally means somebody presses the back button and exits your app. That way, the process is not really killed, but the activity is still stopped, right? So these are different lifecycle events that happen. Now, we can write some code inside the methods, and the OS will call it for us, but we can't create the onCreate method. That's the beauty of these methods also, and that's why they're generally named with some on prefix. So onCreate means that when it is created, the OS will call this function for you. You can't control when it is created. The user, when they want to open your app, then it will get created. So this sort of way of writing code is a little bit of a new thing generally for a mobile developer, that, hey, the events will always be triggered by the OS, maybe on the behalf of the user, but basically by the OS. And I have to write code, keep it ready inside the function, and whenever it will happen, then my code gets triggered. So if you sort of want to play a certain sound when your app opens, like a boot up sound, some apps have it.
Right.
So you write the code of playing the sound inside the onCreate function, and when the app opens, it will play.
Okay. So, just to try to understand this as a guy who's mostly worked on the backend most of his life, you have activities whose constructors are not defined really. The default constructor is used, and then once it is actually created, the operating system decides on when this is going to be created or not using some smart tactics. Let's say that it figures out that, hey, a person wants to actually open your app, so I'll create an object for you, and then it then says that, okay, I have created it, what do you want me to do? And then you say, please play a sound. Okay, here's the interesting thing, then they, let's say, on background, on resume, on low priority, these are all the things that you are saying is basically an on event. So
on event,
you're kind of taking the activity. I mean, it's a class. That's interesting. Again, it has behaviors. So the activity itself has behaviors. So actually, behaviors have behaviors, sort of something like that. Interesting to think of that the submit button on click will do something. So I think you had mentioned this just a second earlier, that HTML also has this kind of a tag like button on click. So you click on it and things happen. Okay. I can draw a little bit of a parallel with the backend engineers on their first day. You know what they do? They come here and they say where's the main function? And we tell them, okay, here's the main function. They go to the main function. They're like, yahan pe kuch nahi ho raha hai. I'm like, oh yeah. It's because there's dependency injection that we are doing. That's one thing. But there's also that the server actually has these methods exposed, and those are like
in most backend frameworks, you have these get, post functions in the controller.
Yes.
So the request comes and the function gets triggered. You are not sort of manually triggering those functions. You're waiting for for the request to come.
Correct.
So that analogy, exactly. So here, any of your logic, you just write it, keep it ready. It will get triggered when that event happens.
Correct.
You can't drive the user to certain things.
Which is interesting. And guys, if you want to know about how these listeners work, or how the server actually is always listening for, let's say, an HTTP request or something, you can have a look at that. But the basic idea is, as an engineer, like Arnav said, 90% of the time you will be like, okay, fine, an event happened. What do I do now? And the complexity also comes from the fact that this event can happen at any point in time. You might have any state. Even on the server, this does happen sometimes. Okay, Arnav, the user, has already paid for a course, let's say. And then you have to behave in a particular way. Arnav has not paid for a course. You have to behave in a particular way. Does that also happen on the mobile side, Arnav?
Yes. That definitely happens. So basically, what I think is once you have sort of gotten to, I would say, the post-event-driven programming mindset, you have come here, right?
Yeah.
Now, for a mobile developer, and I would not just say mobile developer, I would say for anybody working on front end, is to understand that, okay, front end, when you start off, might look very chaotic, and then if you work on a very big code base, then you see that, okay, there are some pieces of my code which is pure logic there, it's very much like how backend code works and like that. But then there's the front end part which is happening event driven, all of that stuff might feel very messy. But front end is actually very simple, and there are just three things that are happening. There are three major problems that everybody working on front ends is actually trying to solve, and that is which is dividing the UI into sort of components. Okay. So the second, you just trying to beautify the diagram, I guess.
No, I'm also trying to just like write down about this just so that we are dividing the UI into components you mentioned.
The point number 2 is basically state management. Okay.
State management. Okay.
State would be like you were saying, that whether you have to check when the button is clicked, whether this person is supposed to be logged in or supposed to be logged out. How do you handle these kind of cases? So that's all coming into the state management piece. Okay. And the third piece I would say is basically, so navigation or routing, it depends on whether we are, working on a web kind of interface where URLs exist. But it's surprising, people who probably have not worked on mobile development would know that on apps, we actually stick to URLs as well. So we use something called deep links, and the format of deep links are very much like URLs. The reason is, and let me just...
deep links. Okay.
Yeah. Yeah, maybe if you can go ahead and just write navigation or routing, you can say.
Navigation, okay. Or routing. And you mentioned deep links here. Okay, yeah, we can get to that in a minute. But okay, so it sounds
deep
like...
links I will actually talk about, let's say, deep link is. If you actually fire a deep link, let's say, FB, / it's a non-HTTP endpoint I'm talking about. Okay, so FB, / and then after that, you, let's say, write, actually U for users, it's FB, / U / any username on Facebook that exists. Let's say my username on Facebook is Champions. So if I write FB, B for Facebook, yeah. So if I write FB, and then let's say this is basically Facebook protocol, like HTTP protocol exists, FTP protocol exists. Think that is an FB protocol. Okay. And inside that, the path is, let's say, /U / my username. If I fire this, the deep link in my phone, actually the Facebook app would open, and it would open on my profile page directly. So apps manage URLs just like websites are managing them.
Okay. So you are sort of calling that app. There is some sort of like a unique at
a particular point inside the app I'm saying that user page and / the user identifier is Arnav. Very much like how URLs work.
Right. Unique.
So the reason why we do it is very simple. Most common websites that I would say most, let's say you can't take an example of an Uber because it does not exist on web. But say you take an example of Facebook or Twitter or a Google, anything. Most of the things that you're doing on app can be done on the website as well. Right. So every page that you open on the app also has a corresponding page on the web. Right. So think of the person who is looking after the business, the product, the architecture. For them, every page has a location.
Yeah.
And that location is the universal resource locator. Right. So when we design apps, although that URL is never visible to the user, for an app developer, we always know which pages are at which location because we stick to the URLs. Because the software engineering world hasn't invented anything better than a URL for this purpose as of yet. Like, how do you sort of keep track of different locations you can go inside the app? Like, so let's say Zomato's app, something that I worked very closely on for a long time. We have a simple routing pattern there. R / some number means restaurant ID. Some U / some number means basically we are opening a user's page. Okay. We have restaurants, we have reviews. Like, net top level entities are not a lot. There are restaurants, there are menus, there are orders, there are reviews, and there are users. Everything else comes in the other part of the complexity, and everybody who has watched all of your high level design videos, they know like how the lower layers of the complexity comes in. But the top level entities aren't a lot. There is food, there is ordering, and that's all. That's all you're doing on that app.
That's right.
So now these routes are very important. Why they're important? Because say you have opened the previous orders page of your app. Right. It shows you a list of last few orders you have done. Okay. So it will show you last 10, 15 orders that you have done. Now, inside every order, there is going to be the icon of the restaurant as well. That's usually how it is. Like even for, let's say, Amazon, you were saying how somebody develops an Amazon app. Now, Amazon would have an order page. Now, in the Amazon order page, in every order, you would have, like, say, a certain button to cancel that order or all of that. And there would also be the image of the product itself, which I ordered.
Correct.
Right?
Yeah.
Now, if I click on that, where will I go? I will go to the product page actually. Right.
Yes.
Now, the easiest way in my UI to sort of tell that, hey, go to this restaurant. This is my last order. I want to reorder from this restaurant. What's the easiest way that when somebody clicks on the restaurant image, I go to that restaurant's page, is that that button click just generates this deep link. Say our restaurant / whatever is the restaurant ID of that restaurant. Just like hyperlinks work. Exactly like hyperlinks.
Absolutely,
work.
yeah.
Okay.
Yeah.
It's very much like, say, on a Facebook app also, if you have a DM with somebody, and if you click on their profile image on the DM, that takes you to the profile page. Right. So in that way, an app does not work very differently from a website. Okay. It's just that you don't see the URLs actually changing on your mobile phone, but they're there. Right.
Yeah. You don't see the top URL changing. Yeah.
You don't see the URL changing, but that's how.
But it's happening.
I mean, there is no better way to keep a pointer to the profile page than just the URL itself. You tell that I want to go to this page. The app will generate that page for you. The app knows how to generate the use/Arnav page.
Makes sense.
It knows that I have to make an API call to user endpoint, get the user data, and I have to generate that layout for this. So the app knows how to do it. So at the end of the day, best apps are going to be pure state machines. It's going to be, you just tell which state you want to reach. It will show you the layout for that particular state.
Amazing. So this is not being provided by any server as such. It's basically the app only saying, okay, like if you're in the API.
Yeah, it's local routing. So that's when I say that when you're talking about front end, we are thinking of three things, just listed down up there. Then dividing our UI into components. Coming to that, expanding on that point, very simply, it's so that we can reuse similar looking things at different places in the app.
Okay.
Once we make a, let's say, restaurant card, we want to use it inside the orders page. We want to use it inside the search page. Why should we like redo the component, right? That's part one. Part two, I'll come back to part two because that's sort of the most complex part, I imagine, because that's where all the design brains are working on. Most senior people on the front-end project generally are working on that.
Okay.
And third part is the navigation. So navigation is important because of this reason only, so that you can go from one place of the app, like a wormhole or like a porthole, to another place of the app very quickly. That, okay, this link to that link, I can just go to this place. Now, what happens is with these single page applications that exist on web, like the apps that people build with React and Vue.js and so on, and mobile apps, they both, what they do is they never actually fetch fresh pages from the server. They fetch data from the server and they regenerate pages on the front end, right? So there, you have to manage which URL you are on the front end itself.
Okay.
What generally happens is like the original concept of why URLs existed is that you enter a URL in the browser and you fetch the page from the server.
Yeah.
Web 1.0.
Yeah.
Web 2.0 is basically, the front end just observes what URL you are writing, and based on that, it fetches only data with an asynchronous call and updates the UI on the front end. So your front end now has to manage URLs. That responsibility you are not delegating back to the server. The server is not generating pages for you anymore. The server is only giving you JSON or XML or whatever raw format data to you now.
Got it.
Right. So this is something you have to manage. Now, state management is sort of the hard part here, because what happens is state is a lot of things. Right. State is, of course, when the user is logged in or not logged in.
One small doubt here. So, for example, like if I change my now that you have actually taken away the responsibility of the server to send web pages, so this is the reason why you need app downloads, right?
Exactly.
Right. So you say, okay, fine. I built Amazon app. You downloaded it. Very good. Thank you. You go to any URI, any of these URLs like Amazon/use/Arnav. I have a particular way in which, a particular structure in which I'm going to keep the image over here. I'm going to ask the server or the CDN, please give me the image. That's okay. But you're basically, you have a particular structure. Colors are set. Everything is set. And you are just getting data. Things which are dynamic, you're getting. Things which are static, the structure is set. You are basically keeping, in the app itself. That's what you have downloaded. That code you have downloaded already.
Yeah. So your app is basically gonna contain all. I mean, these days, sort of more advanced apps, they have dynamic layouts and all. But generally, like a simple app, it would know that, okay, how to show a product page. So for every product ID 1, I fetch data from the server. Product ID 2, I fetch the data from the server. But given the data of a product, given that the product data would come in a certain format, will come in a JSON object, which will contain product name, vendor name, price, product photo, these sort of data. How to represent that on the UI, that is already inside the app. I know that.
Okay.
So my app knows that, okay, if I go to product/1, that's the deep link that I go to in my app, I need to make an API call to fetch details of product number 1, and I have to generate the product page on the for the user. Okay. So which data is to be represented in which layout? That's the stuff that's what basically makes the bulk of your app size, right? So that's what you download basically on the app. And then when say a new update of an app comes, like what's the reason why say an app developer has to keep updating their app? One of the biggest reasons is because product teams keeps on designing new layouts, so you have to sort of update the new layouts. So if say Amazon decides to sort of update their product page to a different layout, you have to ship a new version of the app which contains the new layout.
Yeah, and it kind of depends on like how much do you want people to know about it. Like, okay, I'll ship it, but I won't force people to download the app.
Yeah.
Sort of thing. Okay.
Yeah.
Okay. Interesting. Okay. So
now, and then building the layout is the part where you want to sort of break it down into components so that you can reuse pieces, right? And when we talk about components, one thing is like components are not purely just views. Generally, components are a combination of view plus the logic.
Yeah, that's what I was thinking. That's what I was thinking. Like you have the same kind of behaviors also, right? With those components. Like for example, you're entering text. Yeah, you want the same kind of behavior.
Yeah. So for example, let's say there's this notification icon. Let's say many apps, like the Facebook has or Twitter has that notification with a red dot containing how many notifications you have. Right. It's a common pattern everybody's using. Now what happens is that component actually gets reused. On the home page, it might be at the bottom tab. When you go to the profile page, it might be at the top right corner somewhere. When you pull out the drawer from the left side, it might be somewhere there. So there are different places that particular component comes up. Now, that there are certain properties of that component. It's not just the UI. It's also like how many notifications are there. That number also has to be represented inside it.
Yeah.
When you click on that icon, it does the same thing. Whether you click it from the tab, whether you click it from the top, whether you click it from the right side, it will take you to the notifications page. So a component is basically an encapsulated view plus some logic associated with it, and then you can reuse it and use it at different places inside your app. And then in terms of mobile development, we have been doing this actually for a long time. In web, I would say I think Facebook sort of mainly Facebook and Google via Angular and React sort of pushed for this way of development. Because they figured that they, say for example, Facebook has this chat thing, which they can sort of tap in, like basically, tag you with any screen that they have. Like at the bottom right corner, they can just pull in the chat of like, whether you're on a profile page or a newsfeed page or any page, they can sort of attach the chat at the bottom right corner. Why are they able to do that? Because they have created it as a standalone component that can work independently of where you're putting it in. Right? On mobile, you have to do the similar thing. Right? There are going to be a lot of these pieces of UI plus logic tightly coupled together. You just want that to be used at different places inside your app.
Got it.
So that's sort of dividing the UI into components and the layouts.
Got it. So yeah, it's also probably going to be using the same kind of data, but you don't care. I mean, logic will take care of that. If the logic is the same, that possibly, like most likely the data also that you're using is quite similar, but it doesn't matter. As long as the logic and the route is the same, you can handle anything. Okay. So this is interesting. Okay. So you basically are dividing into components, standard software engineering practice. You want to break it into things that you don't repeat yourself. You test it once and it's tested forever. You're not doing it again and again. The other thing that you're doing is you're actually doing routing, which is also something that, which service do you want to send it to? It's like sort of like that. That's how I'm remembering it. Like, you want to send it to this page or that page. Okay. Makes sense. Now, now let's try to tackle this beast a little bit. If you like at a high level, what is this state management?
So state management, why it is a beast is because any real world product does not dump some CRUD APIs onto the user. It gets more complex than that. And in what ways does it get complex is, let's say somebody was on the screen and they were trying to fill a form. Now, this form, obviously, once they fill that form, they will submit it to some post endpoint. But till they have not submitted, who manages the current situation? The front end has to. Now forms are going to get increasingly complex as you make real world products. Let's say you make a fintech product. Your onboarding page will have upload Aadhaar card. So you uploaded the front side and you have not yet uploaded the back side.
Yeah.
What will you do? You will go out of your app, go to the camera app, take the photo of the backside, come back to your app and attach it or something like that.
Yeah.
So during this whole maneuver, you had this partially filled form, uploaded photo, which is not actually uploaded to the server yet. It says that you attach it. So attach and then you upload.
Correct.
So who is managing all of this? And this is where sort of the majority of the legwork, like when apps grow, when you have a lot of users, when your product features increase, majority of your design decisions are about how do you manage the state properly. Right?
Okay.
So this is about one piece, which is how do you manage what is currently basically showing on the screen while the user sort of wanders around at other places in his mobile phone and keeps your app in the background. Okay, that's challenge number one.
Okay, so where you left off, sort of.
Where you left off, exactly. So where you left off and whatever data that you had already put inside that app, how do you sort of keep it safe? Now, very interestingly, you will see that on the WhatsApp app, if you're on a chat, you type a message on the input box and you have not sent it yet. At that stage, if you close the app, even like flick it away from the recent screen, or even if you restart your phone, you open the chat with the same person, you will see that half-typed message is there. So it means that they're saving the state of the input box. Okay. And they have to manage it in a graceful way. Right. Maybe you have attached a photo and you're writing a caption. At that stage, if you leave the app and come back, so they have to sort of maintain, either they have to maintain a pointer to which file you had attached so that they can reattach it, or they have to actually capture the file as bytes into WhatsApp's app itself. Design decisions again, right? I mean, there are pros and cons. If somebody attaches a photo and they have not yet sent it, at that point, do you as the app developer actually transfer the bytes from the files into your app's memory itself? Do you just keep a pointer to the file location? One is a memory heavy operation, other is more reliable, but design decisions. But you have to take a decision. You have to take a call of this.
What's the benefit? What's the benefit of actually storing it in your app? Like,
interesting. So what if you have Google Photos and every time photos are uploaded to the cloud, Google Photo cleans it from your phone's local storage?
Oh, okay. Yeah, you're right. Yeah, I didn't think about it.
So you attach a photo to WhatsApp, but you haven't sent it yet. Google Photo meanwhile cleans that photo from your disk. WhatsApp can't pick it if it was just a pointer to the file.
Correct.
But if they have kept a local copy, then they can use that to upload.
So at this point, you kind of make a partly engineering decision, partly product decision.
Correct. Yes.
That's.
You look at the trade-offs. Like losing that photo, is that acceptable? If it is not acceptable, then you make a local copy. If your app's local storage bloating up is something that's not acceptable, you have to take the design decisions. And then these become product decisions in a way, because you would have people using your app on a low resource phone. They might uninstall your app if your app's local storage is bloating up a lot. They might not uninstall WhatsApp because of the network effects. They can't live their life without WhatsApp. But you are some, fresh new messenger app. They are very happy to uninstall you because you are taking a lot of storage. So
makes
those
sense.
are only engineering plus product calls.
It's kind of like, like you said, absolutely. WhatsApp can afford to add in, let's say, 50, 60 MB. Okay, I'll go like, new app, I'll go like, wow, why do you use it?
Exactly. Right.
That makes sense. Yeah. Google Photos again can take as much memory as it possibly likes. I'm not going to remove it. Or Google Search, for example.
Yeah.
Google Chrome.
Correct.
Yeah. Okay.
So, for example, a very real incident that happened at Zomato when I joined. One of the first assignments that I had, right from the CEO himself, Deepinder, said that we are scaling up to smaller cities. People are using it on smaller phones, lower GB RAM, lower storage space, lower internet. They are uninstalling our apps because the app is too big. We had a hunch. Let's investigate, see the numbers, see what happens. So we did a lot of things. We reduced the app size from 22 MB to 16 MB. Uninstalls fell a lot. People stopped uninstalling the app because, you ran out of storage. The OS suggests you, do you want to delete these apps? Yeah, like, okay, 22 MB, go away.
Yeah,
right.
of course. Yeah.
So that then we realized that so when somebody is sort of landing on the homepage of Zomato, they're showing this list of restaurants up there, right? What is the cost of each? We would call it a rail because it's like a railway track and it is infinite because you keep sort of scrolling infinitely down. So what is the cost of each rail? Because each rail is basically, it would be either a restaurant or it sometimes can be some advertisement also. It could be some, where Zomato is sort of pushing you to order some new food item or anything like that. Right. So each rail, basically each horizontal strip in the infinite vertical scroll of the homepage. Okay. This, incidentally, is a design that is used very universally across most apps. Like today, 90% of apps are infinite vertical scrolling lists.
Instagram.
Twitter is that, Instagram is that, Facebook is that, food ordering apps are also that, Amazon on mobile is also that, right? It's a infinite vertical. Now, here, the sort of the rail could be, let's say, a snippet which is showing a restaurant. Now, the restaurant would have a cover photo. That cover photo obviously has a cost. It has to be downloaded from the internet. But more than that, it is cached also. So every photo has to be locally cached because you don't want the user to sort of scroll up and then immediately they scroll back down and again the photo will load. You don't want that.
Yeah.
So it has to be cached locally. Right. So if the cover photo is worth say 700 KB each cover photo, then obviously 700 KB per rail you are downloading. Plus if the user scrolls through 200 rails, then 200 into 700 KB they are also storing in the cache. Right. Which will sort of increase your local data size of the app.
Right.
If that bloats up, user will still want to delete your app. Your app's local data size is increasing a lot. I don't want this app here. Right.
So your cache is huge.
Yeah. And people would be surprised. Most people, if you're using a good mobile phone and you don't run out of storage, usually a 128 GB or 256 GB phone, you don't notice that. But people on 8 GB, 12 GB, 16 GB phones would be noticing that. Look at the local data size of Facebook. It generally goes up to 1-2 GB because so much doom scrolling you have done, or Instagram, so much doom scrolling you have done, and all of these photos get cached because you don't want to sort of the photos that you immediately scrolled away. You don't want to re-download them. So they will be cached for a while. And then your general system design cache knowledge is gonna straight up get used. Like how soon will you invalidate, what LRU mode you're using, or what you're using. Obviously, that will come into the picture. But in general, if you just reduce the cost of the rail, then your cache size will also reduce, your network cost will also reduce.
Yes.
Right. So that's one of the things that we did at Zomato was we figured that we will have a separate endpoint for the restaurant headers.
Yeah, it's not so intuitive actually. If you reduce the size of the cache, the general engineer will say that, hey, you are making more network calls. That means.
Yeah. But if you reduce the cost of the rail itself.
Yes. Now it makes sense.
If you reduce the size of the photo itself, then you reduce both of them together. The cache reduces, your total network, the bandwidth usage sort of also reduces.
Got it. So here's the interesting thing. This is actually something I think in Programming Pulse, guys, if you are looking for this, there's a book in the description. So it's a very old book. The guy also did the same thing. He had 1 or 2 resources and then he cached it and then he made sure that only those would be cached. So the cache size reduced. The time also reduced because there was thrashing going on, one, and the other thing was that he was doing a lot of network calls, I think. So database calls, So, okay, that's an interesting, I think it comes across in engineering very often. If increasing the size of the cache is not always going to make the thing faster. It's sometimes reducing the size of the cache also. Yeah.
Exactly. And then in some places you start fighting with the OS as well because for the better of the users actually, the operating system start putting a lot of constraints, and over the last 5-6 years, those have increased. Like if your app is sort of exponentially increasing the local cache size, your OS starts very aggressively garbage collecting the cache, or it sort of reduces the performance of your app. It can put your app into a low memory mode if you are spiking the CPU or the memory usage a lot. These kind of safeguards and guardrails have gotten created over the last 4-5 years as a lot of times engineers, either because of evil intent or because of lack of engineering skills, have built apps which sort of abuse the resources that are available. And then whom do you complain against? You're like, I bought a Samsung phone, battery gets extinguished in 5 hours, I don't want to buy a Samsung phone. So the manufacturers and Google who is making Android or Apple who is making iOS, they have to sort of come in and say that, hey, we will sort of put some control on the apps who are abusing resources. So
makes sense.
Again, some places like how many number of API calls you're making, beyond a certain number of calls you go, you get throttled by the OS itself. So you have to keep in mind those. You can't just sort of abuse the cache size or the number of network requests. Even if your user is on a great internet connection, you still can't do that because the OS has some limits. You have to fight with them as well.
So it's doing the rate limiting for you, sort of, and some sort of like what do they say? Like it's capping.
It's best if you do the rate limiting before the OS does it for you.
मैं क्या करूं फिर जॉब छोड़ दूं?
Okay, interesting. Now coming back to this thing that let's say you left off at you're about to buy something, you added it to the cart, and then you left. So you come 4 days later and still in the cart. So this is going to be in the app or it's going to be in the database only. Probably you're going to put it in the database only, so that if I come to my desktop, then I should be able to. Okay. That's interesting.
Sometimes, but not always. Now, here's the thing. What we do is, say, at Zomato, we generally used to put that on the app, plus send a notification to the database. So what happens is, while pressing the checkout, while payment, let's say, somebody's payment gets disrupted because of some reason or so, right? So we keep a copy of what they were trying to order, and we also keep a copy of what coupon they had applied and all of that stuff. We keep a copy locally, so that if some of the app crashed or something happened, they come back on the cart. One thing we have to do is we have to recalculate the cart because that coupon might not be valid anymore, or the restaurant's ETA might have shifted a bit during that time, all of that stuff. So we keep a copy of the server as well, right? But the server's copy was generally for safeguard purposes, and we actually use the client-side copy only because we just the item that you're trying to order could have run out of stock at the restaurant anyway. So what happens is, like, if somebody comes down to the cart page, based on what data we had stored, that okay, this person had put a chicken tikka butter masala on his cart and they had applied a try new coupon. So we have to reapply that and make a fresh API call and see if we can create this cart again or not. With somebody like Amazon, what I've seen is that they generally keep it on the server side, because if you place something on your cart and then you go to other computer and you try to order, you will see the cart is already there. So they're keeping it on the server side. Again, these are part product, part engineering calls, because you have to see like what is the user behavior and then sort of decide on that.
Makes sense. And this is like you're kind of caching on your side, like I don't know whether to call it caching. Like, so for me, like there's one source of truth.
We use a local SQLlite database to store that stuff. So and the SQL databases exist within apps as well. So file-based databases are used. So generally, in the Java world, people use H2 database a lot. But on mobile, what is more prevalent both in iOS and Android is SQLlite databases. So
SQLlite, I've heard of this. Yeah.
So it's a little more lightweight than something like MySQL kind of things. You can't do very fine-tuned queries and all, but it follows all the ISO standard SQL practices. So you can make a normal SQL query on it. So it's a standard relational database only, but it's a file-based DB. It's not a server-based DB. Why it is okay to be file-based is because now here another little thing that's different from, let's say, backend developers is that this database is not used by more than one process at a time. Every app has its own DB. So read locks, write locks are not a problem now anymore.
Every app has its own DB.
Yeah.
Okay, that's very interesting. It's like
if they want. Some apps might not want to.
Can you read off somebody else's DB? No.
So early on, back in the day, it was possible. Now it is not possible because every app runs in a container. Sort of like think that every app is running in a Docker container. That's how security is done in Android now. Using a process which is borrowed from Linux called SE Linux, Security Enhanced Linux. So we basically C group it. So for every app, there is a user ID and a process ID created. So user ID and process ID are bounded to each other. So user ID 1 cannot access process ID 2. basically.
And you say that 50 MB se zyada, no more than 50 MB will be allowed today.
Yeah. So those kind of resource allocation stuff also you can do. So basically, every app is running in a Docker in essence, today's world. But back like 5-6 years back, it was possible for one app to read another app's database. Now, if you want to do that, you have to create APIs between apps. So they are called content provider APIs. So basically, the way every app reads the contact book is via one such API only, because the contact book is also an app.
Okay. I'm starting to get you guys are behaving like services now
every app is a microservice. Truly, yeah.
Okay, that's interesting. So every app has its DB. Like when you said that, I thought, okay, service. every service has its DB. File-based DB is pretty interesting, but you have a layer of SQL on top of it. You are basically storing the state there, or are you is there a table, like state table or something, or like how?
So the structure there depends. Like for storing the cart, how would you go about? It depends. Now for cart, why do we use the table, and why not just sort of dump a JSON itself of the cart? Why that is because people can have multiple unfinished cart on multiple tables. So for that basically we have a DB kind of setup. I think Zomato's case long back, what we would do is we would just store it as object dump only, because we would store only one cart at a time. So if you are added 2 items on one restaurant, then you go to another restaurant, try to add items, then we say that your temp cart is overridden by this one. Do you want to go ahead? Now we allow multiple temp carts, because Zomato allows multiple orders also to be placed simultaneously. So multiple temp carts are allowed as well. So we keep a table. The tables now actually coming there. So tables are also useful for something else, which is a lot of the data is very important to be live, and some data can be okay even if it is not live. Now, to take an example of that, and this is a very interesting exercise. I generally new Android developers, I tell them to do it, and then they are also they have not noticed it before. So open Twitter, for example, right? So open Twitter and take a screenshot. What did you see on Twitter? Okay, homepage. What were the tweets? Now, keep your phone shut down the Twitter app. Don't open the Twitter app for an hour. Okay. Then an hour later, turn off the internet. And after turning off the internet, open Twitter. And you will see your feed has changed. So Twitter on the background fetches fresh feed and stores it in a DB. And then when you open the app, it does basically, now this is where sort of some actually hardcore high-level design concepts sort of come in. What you do is whenever you're trying to sort of refresh the feed, what do? You generally make 2 simultaneous calls. You make one call to your local DB and you make one to the API. The local DB call obviously ends quickly. You show that data, then the call from the API ends. If there is fresh data, you basically, what on Twitter you will see is that you will open it. You will see new tweets available and there is a little pop-up at the top and you can scroll up. So basically, whatever was cached is there on your screen. If fresh data was available from the server, it sort of puts that on the top. So you can scroll up and see that stuff.
Okay.
So using the local DB, like legit as like a store of the remote data, not just as a throwaway cache, it's actually properly storing. And you can actually interact with tweets when you don't have internet as well. You can like a tweet, you can retweet a tweet. It will record that in the DB and it will sync that state when you have internet connection available.
Yeah, it's more than a cache. It's definitely more than a cache.
It's a local copy of a DB. So actually, there are some databases who have gone very, they've focused themselves onto mobile development in a way, and they've turned themselves into a almost SaaS kind of a model. There is CouchDB. So CouchDB has a CouchDB mobile version. So with that, what you have is you install an SDK on your mobile app, and they do this syncing on their end. So on your backend, you store something on CouchDB. Your app can sync with the DB. The SDK internally handles the fact that it can fetch fresh data, or if fresh data is not available, it can fetch the local data and it can sync the local data with the server. It can do. Obviously, with apps at scale, generally off-the-shelf solution like CouchDB does not work. So you have to actually design this syncing mechanism yourself.
So the interesting thing is like CouchDB. Like if I'm storing data on my CouchDB, usually if you write a service, then nobody can hit the DB directly. So this is interesting. It's like a heartbeat sort of.
Has a backend SDK and a frontend SDK. So you have to integrate the backend SDK onto your server and the frontend SDK on your mobile. And so there is a logic layer on top of it, which they are providing as a sort of semi, SaaS and SDK solution.
Got it. It's very, very interesting. It's like you have a distributed database actually.
You have a distributed database, and you are distributing not across servers but across clients now.
Yeah. It's like a proper, like, even this is the part of the distributed database then. Like you send stuff, I send stuff.
Yes. And here, very interesting is the way you're shorting it is that your master contains everybody's data. The sort of client side data for your phone's copy needs to have only data that you have access to, and my phone's copy needs to have only data that I have access to. So on a database starting level, it's a very different challenge then also, because my copy would never have any data that your copy has. Like, it's a very different thing. They are not the replica kind of copies. They have a subset of the data which I am supposed to view.
Oh, got it. Yeah, there's a very small range or set of things that you are actually interested in. But it's also sometimes difficult to define which range will you be interested in. Like your profile changed. I am interested. I want to go and check that profile out. Okay, now you need this data here. Here's some data.
Yeah. So those things will generally come on demand. But something like feed, which is supposed to become whenever you open your app, the home screen, that gets cached on your DB. And then in this sense, when we say cached, it's not really working as a dumb cache. It's way smarter than a simple,
initially, that's true. Initially, so if you, I personally at least, as a backend guy, I used to think that, okay, fine, you guys are just querying the API and that's it. It's source of truth to yahan pe. But this kind of cache is like basically you're writing to the cache, you're reading to the cache. I'm still calling it a cache. I don't know. I should call it a DB.
You should, everything because for a social media site, say for example, where you let the users interact with the offline cache as well, you start having reconciliation problems as well. Now you have to that problem has to be solved in the backend. Obviously, that won't be the front-end engineer's problem. The headache will get shifted to backend. But say I have Twitter on my laptop open, and I have Twitter on my phone open. On the phone, my internet is patchy. And while it was offline, that time I liked a certain tweet, and then I went to sort of the website, liked the same tweet, and then these two things have to get reconciled. It can't be two likes, right? So.
Yeah. No, it is something which is, and also if you switch off your phone, it doesn't go away. So that is persistence. Okay. So
in fact, there is another layer of persistence, and Twitter's app I use as a example a lot because Twitter has gotten these things very nicely sort of locked on, and then the reason is because they have been doing a very simple thing. It's just a list of posts for 12 years, 30 years. They're doing that only. So as a result of that, they have been able to sort of on the engineering side develop a lot of good things. Is that if on the feed you have scrolled some way, like maybe you're halfway down the feed, some 15, 20 tweets down and reading a tweet, at that stage, if you kill the app, restart the phone, open the app again, the app will open at that half open state of the feed, and that's very difficult to do as a mobile engineer because you are not just generating a list from data again. You have to, of course, do that. Plus, you have to resume the view at a half scrolled state where the user was. So where you had scrolled to, you are sort of saving that as well. So this happened to me first time. Once I was just sort of browsing out almost 1% battery, and suddenly the phone died. And then when it restarted, I went to Twitter and I was like, hey, this is the tweet I was browsing, and there's like I'm halfway scrolled down. It opened at this level, and I realized that that's. Obviously, it's an engineering challenge. It's a very difficult engineering challenge to actually solve for this, but they have done that, and it's very good. And other social media apps also try and do that. Let's say Instagram, extremely popular, but they don't do it, right? So it depends. It's not very easy to be able to implement that for every user.
Amazing. Okay, so in case guys, we have any blogs on that on Twitter, we'll be posted in the description. But this is amazing. Thank you, Arnav, for actually taking us through like step by step, guiding us through what happens on the mobile engineering side. Initially we figured out how does it start. So if you're fresh out of college, or if you're mainly into lead coding and you have never done any engineering, this is you can start with, okay, the thing is event driven. That's good.
One quick thing I want to add here is that before starting with any mobile framework like Android or iOS, I would still say spend a month building web UIs as well. It's going to help a lot to sort of get you into the mold of a event-driven architecture where things start when somebody clicks a button. And basic front-end web development knowledge does not hurt anybody. It's going to be useful for you anyway in life. I would suggest that you do that for a month and then start with Android. It will help you a lot.
Makes sense. Yeah, no, absolutely. On-click is something that I have done earlier. So obviously, I think I understood what you're talking about. Then, okay, so after that, we went to the three major parts, let's say, of designing a UI. The first one would be dividing the UI into components. This is primarily so that you can, you don't need to repeat yourself, both in terms of what you create as a view and the logic that each of these components will have. One of the examples you took was actually building a notification component, let's say. You can reuse this here, you can reuse it anywhere you like, depending on the product requirement. Second thing was navigation. Interesting to know that you have something like a URL which you can point to whenever you want to access a particular resource or send people to a certain place. Most interesting by far, in my personal opinion, was the state management. Okay, you need to know what's happening with the entire life cycle, right? Like, okay, where you left off, what you did till now, maybe you want to basically note that down. And how do you store this? You're storing it in a DB. SQLlite is a popular database, and you have to figure out like what kind of data is this? Is it live? Is it not live?
Point number 4 here is that when you resume, how do you sort of retrieve this data back, and how do you sort of retrieve the stored state back and then merge it with the live data from the API?
Okay, how do you restore the view?
Yeah, how do you restore the view?
Okay, yeah, that's another interesting thing that I think you clearly mentioned that there's multiple ways in which you can do this. One of them is to store the state as like table entries. The other one is to just dump the objects and then you pull them back and you kind of know where you left off. Okay, caching was pretty interesting. Data limiting was pretty interesting. One of the databases, which is CouchDB, I have to read more about this. Interesting that they are actually taking this approach. I don't know if anybody else is doing this. It's going to get pretty popular if they solve this problem itself. Like,
so technically Firebase also does that in that sense. So Firebase became very popular by doing that. So they have a local caching solution inbuilt into the SDK itself. Okay.
Firebase also does that. That's interesting. And then a few other details like in terms of caching and how the app runs. Actually, that was also very interesting. So more than anything, I think Arnav, at the end of this, a person who's going to be looking at this video is going to go like, okay, I think I understand what are the major responsibilities of a mobile engineer. I think some of them are common to mobile. I mean engineering in general, but some of them are quite like specific to mobile engineering. Okay, awesome. Arnav, anything that you would like to share with us before we?
No, I think that's sort of pretty cool. I just shared a link on the channel. Maybe if you can open that. So if people can just look at a screen on the left side, that's a general, let's say, any news article screen. There's a header out there, and there's a body part. There are 2 articles inside it. The right sidebar has 3 cards inside that. Okay. Immediately look at that and start imagining this tree on the right side. So the tree is what the top node is the full body. The left, the first node is the header, the second node is the body, and the third node is the sidebar. The second node has 2 elements inside it, the third node has 3 elements inside it. So this is exactly what's happening when you write HTML or XML as well, right? Because if you sort of represent your HTML as a tree, you'll be able to represent it because inside a div you put a paragraph, inside a paragraph you put something, and then all layouts work this way only. Because if you look at any front-end development framework in that sense, so Android is using XML, iOS also uses XML, but they use I think Swift UI these days. Swift UI also has a tree-like structure, and then people who are working on Flutter same tree-like structure they're using. People are working on React, they have the JSX, again a tree-like structure. If you can get to a point where you have built a lot of UIs, where you look at the left side and that right side tree automatically forms in your head, I think half of the battle is won. You would be a very good UI developer at that point, where components start forming in your head. So I think a good exercise would be, as a front-end developer, try to look at pages, like favorite website that you have, go and look at a page and try to think, okay, how do I divide it into components and how would I go about sort of writing the code for that? That would be a very interesting exercise to do and sort of make you a very proficient in sort of thinking of UI in terms of components.
Amazing. Yeah, no, yeah, I never think this way. Maybe that is something.
People say that, hey, does tree data structure come in use in front-end development? I tell them that, yeah, it does. There are actually proper tree traversal methods also in Android development. There's find view by ID, which are to traverse the tree and find a view, and all of the things that you learn in DSA classes, like how to optimize traversal of tree, those things are all useful in front-end development as well.
Oh wow! Okay, so this is like those. Do you guys run any tree algorithms? I hope not. No. Okay.
Yeah, it does. So those are generally abstracted away. You generally call something like find view by ID, which finds something in the tree. But then the traversal algorithm is there inside, and then sometimes you might have a better way to traverse it than Android's default method, because you're trying to access a tree in a certain way, going to delete a node from the tree. So advanced level UI, complex UI, where things floating on the screen, something rotating, these kind of things happen. Those places we have to actually do the tree traversal like a tree data structure properly. That will generally come at an advanced stage. It's not something that you will encounter in the first 2-3 years of your career as an Android developer, or iOS developer, but it will come for sure, where you actually have to traverse the UI like a tree data structure.
Okay. That is, yeah, that's something that I think the algo guys will love. Okay, so this is great. Thank you so much, Arnav, for actually taking the time and coming here. Thank you so much for sharing so much useful and I think actionable info that people can, a person like me who's never done Android or iOS or anything on the mobile engineering side, I can look at this and go like, okay, yeah, makes sense. Yeah, I think I think what the intent is pretty clear. So awesome. Again, thank you for coming here. Bye, guys. If you like Arnav's talk, he regularly posts on Twitter. He's got some excellent resources by himself actually on mobile engineering. He's got a few threads on Twitter. You should definitely check it out. We'll link it in the description. Arnav, also, thank you for coming. And any last words that you would like to share with our users?
No, nothing else. I think it's a pleasure. So I have watched a bunch of your system design videos and I've always loved them. So it's totally a pleasure to be here and talk about this. And I think that it's great you're doing this because talking of mobile development in a system design way, it's not something that frequently is done. It's great if people get some good insights out of this talk.
Absolutely. I think it's going to change and it's so natural here. But